Hello viewers and my dear students. Welcome to session 3 on problem 6 on analysis of beams. Here I'll be giving you a demo on simply supported beam with uniformly varying load and a pointed load using Ansys Mechanical APDL to obtain bending stress and deformation diagrams. As you know, this is session 3. In session 1 and 2, I've concentrated only on reaction solution, shear force diagram and bending moment diagram both by theoretical method and Ansys methods. Now in this problem, in this session, I'll be concentrating only on bending stress and deformation diagrams both by theoretical as well as Ansys methods. See here, this is the problem given. This already you know. Okay, for this problem, you have a bending moment diagram already drawn. Okay, and once you get a bending moment diagram here, 120 kilonewton meter is the maximum bending moment. Okay, 120 kilonewton meter. You have bending stress is m into y by I, maximum bending stress. Maximum bending moment also 120 kilonewton meter. You substitute here 40,000 kilonewton per meter square you get, or 40,000 into 10 to the power of 3 Newton per meter square, or 0.4 into 10 to the power of 8 Newton per meter square is the thing what you should get. That is actually equal to 40 into 10 to the power of 6 Newton per meter square or 40 MPa. That means here it will be linear. Here throughout it will be, as you see, 120, no? 40 MPa. Okay, here you show 40 MPa, 40 MPa and cubical variation to 0 here. And as you know here, I divide into 10 equal parts. That is why you have a small residue here, small residue here. Okay, if you divide into more number of equal parts, this will be almost 0 only. This I have taken from Ansys plot. Okay, but actually for examination purposes, you do the same thing. Same bending moment diagram only you draw, but instead of 120 kilonewton meter and 120 kilonewton meter, you write 40 MPa. Okay, in that way, the bending stress diagram has been drawn. Okay, now we'll go for Ansys to verify this. We'll go for Ansys to verify. As you see, I've already created one change job name and also I given the title and all that. These things you need not give also. Even without that, you can get it. Okay. Now it's better you create a separate job file, that is change job name. It is better you do that and give a title also so that you will know what exactly you're doing also. Okay. Then you go for preferences, structural. Okay. Okay. Preprocessor, element type, add, edit, delete, add you go, beam, 2 node 188 you take, just say okay. Okay. Then material properties you go, material models, structural, linear, elastic, isotropic you go, and you know very well it is 210 GPa, E9 you take. Okay. And Poisson's ratio also 0.27 in the way we have done earlier, you do that. Now it is 210 into 10 to the power of Newton, 10 to the power of 9 Newton per meter square. Your modeling should be in, that is loading should be in Newtons, modeling should be in meters. Okay. Just say okay. Material exit. Okay. Then you take section, beam, common section, you take 0.2, 0.3. Let's say okay. Okay. Now once you do this, go for modeling, create key points in active coordinate system. 1 is 0, 0, 0. 1 is 0, 0, 0. You just say apply. Then 2 is, it is 3, 0, 0. You apply. 3 is 4.500, you apply. 4 is 600, you apply. Then 5 will be 6 minus 1. This is the orientation point, you have it particularly for bending stress, as I've been doing in the earlier sessions and all that. Now once you do this, create lines, straight line, click on 1 to 2, 2 to 3, 3 to 4. Okay, create on that, you just say okay. Then once you do this, Then you go for meshing, mesh attributes, picket lines, click on all these lines. Please be careful now. Click on all these lines and compulsorily pick orientation key point. You just say you have to make it yes, sir, because I have to rotate the beam by 90 degrees so that the orientation is proper and loading is proper. Okay, that is why you make it yes. Just say okay and click on this point 5. Don't forget. Okay, click on 5 and say okay. Okay, then you go for size controls, manual size, lines, picket lines. Take these three, say okay, and I'll have only 5 because as you know, more the number of points, more work you'll have. Okay, so at least when you practice, you divide into 10 equal parts or 20 equal parts, do it slowly, you'll get a better accuracy in results. Okay, now I've taken just for the demonstration, I'll take 5 divisions. Say here 5, 5, 5, then mesh, lines, pick all I'll do. Okay, mesh lines, pick all I'll do. Now if you go here, list elements, node attributes, it is only 15 elements. Okay, it's correct now. Now if you want to see whether the orientation is proper or not, style, size and shape, so display element on, you just say okay. Then you see here your orientation is proper. You can clearly see, okay, this is 0.2, this is 0.3, okay. The loading should be on the top surface. Then it will be proper. Okay, that is why I have made this. Okay, then you plot controls, style, size and shape, you remove it off since you know that it's all properly done. Okay, now you just say plot lines you do for better understanding. Plot lines you do. Okay, now you are loading. Now the pre-processing stage is over. Now we will go for the solution phase. Loads, define loads, apply, structural, displacement, on key points. You click on this, just say okay. UX, UY, UZ, rotation X, rotation Y, you make it 0. Okay, rotation Y, you make it 0. Just say okay. Okay, then force moment on key points. You take this point, just say okay. Fy you take, and it is minus 80,000 newtons, correct? No? Minus 80,000 newtons. This is minus 80,000. Now be careful. Pressure on beams, you have only 1, 2, 3, 4, 5. That means it is 40,000 Newton per meter. 40,000 or 40 kilonewtons per meter or 40,000 Newton per meter. That means it is divided into 5 means I have to have 8,000, 8,000, 8,000. That means 0 to 8,000, 8,000 to 16,000, 16 to 24, 24 to 32, 32 to 40 you have to do. Okay, carefully you do. Pressure on beams you do. Click on the first one. Say okay. Don't change the load key and all that. But be careful. 0 to minus 8,000 you do. Otherwise, the orientation will be wrong. Your loading will be improper. 0 to 1 minus 8,000 you do. Okay. Then once you do this, again you click on this. Okay, say minus 8,000 to minus 16,000 you do. Okay. Then next you click on this. Okay. Minus 16,000 to minus 24,000 you do. Okay. Then you click on this. Okay, you do. Minus 24,000 to minus 32,000 you do. Okay. Just say okay. Then click on this. Minus 32,000 to minus 40,000 you do. Just say okay. Now it is correct actually. You just say fit and plot controls, plot, multi-plot you do. Now you get beautifully, that is uniformly varying load and a pointed load, everything is over. Now once you do this, okay, now what you do is, that is solution phase, solution, solve, current LS you do. Just say okay, it takes time. Once you have to get the solution is done message. Okay, solution is done message you got. You just say close. That means you are doing properly till now. Okay, once you do that, general post process you go. Very important thing, because once you have got correctly, once you have done correctly, first you check whether the list results are okay. List results, reaction solution you just say, all items you say, okay you say, now it is key perfectly. Node 1 is 60,000, last node is 80,000. This is 60,000. This is RA is 60,000. RD is 80,000. It is perfectly okay. In that way, this is also one very important result. What you have to tabulate. Okay, 60,000, 80,000 at node 1 and node 22. Plot nodes if you do, you will know that as I've done in the last session. Okay, now once you do this, then you go for element table, define table, add you do, by sequence number you go, SMISC 34 you do, you just say apply, by sequence number you go, SMISC 39 you go, just say okay. That means 34 and 39 will give us bending stress diagram. This is item and sequence number, this is item and sequence number. 34, 39 combination will give us bending stress diagram. Okay, in that way, plot results you go, plot results once you go here, contour plot, line element results, 34 and 39 if you go, you are getting a perfect bending stress diagram. Okay, see here, this is a linear variation. This is, I have divided into only 5 equal parts now. The 1, 2, 3, 4, 5. This will be, as you know, see, 0.4 into 10 to the power of 8 or 40 megapascals. Correct, no? 40 megapascals. This is 40 megapascals, red one, as you see here. 40 megapascals. And you have a small leftover here because I have divided this into very small, only 5 equal parts. That's the thing. That is why this is enough for the examiners, because if you divide this into more number of equal parts, more work you will have. But at least to show it to the examiner that you have understood the principles and all that, this is enough. 5 or 10 you do and show. See here, this is also 1, 2, 3, 4, 5 I done. This is also 5. This is also 5. In the same way, this bending stress diagram, I got it properly. Then deformed shape also. This also plot controls, right, meta file, invert white and black. This is another very important result. What you have to show it to the examiner or write it in the records. Then plot results, deformed shape, deformed plus undeformed. This also is a very important thing. This, if you have done it correctly, this 0.004895 meters, because I have done everything in meters, this is 0.004895 meters is the correct thing what you should get. This also you have got. Did you follow? That means we have got deformed shape also correct, and line element result, that is this bending stress plot is also correct, and even if you go for list results, reaction solution is also correct. In that way, all are proper here. This problem has been done correctly in all respect. Okay, then plot elements if you do, and you can even show this plot controls, animate, animate over default results you can see, and you can see use some, no, okay, you can see this, how it deforms and all that you can see. Okay, how it is getting deformed and all that you can see. The deformation animation plot also you can see. In that way, I've shown you all the things what exactly is required for this problem. Okay, plot elements. In this way, I have completed this problem in all respect. Okay, thank you very much for viewing. Thank you, friends. Thank you.